Okay, so again, I'm Alex de la Rosa Escobedo. I'm an information security engineer for Salesforce. I have been working here for the last 7 months. And I want to talk about how can you use Packer to protect, and harden your systems, but basically creating an image release process, and you can get security wins out of it. And first, I want to say thank you to HashiCorp for hosting these meets. I'm really glad we can have this type of events. And I also want to thank all the attendees to these events because obviously it's a huge thing and I love it. Also, I want to thank my family because obviously they are a huge push for me and they have been really supportive while I have been working on the presentation and all of this. So I want to talk about why I'm here. I first of all I want to talk about why do you need to build your own images. Second of all, I want to tell you how to build images in an efficient way, at least on what my opinion of an efficient way is, and also the why and some ideas on how to keep them in a release process and why this also important. So why you should build your own images, and probably this is a realization on some things that you have been missing. You can get faster application deployment by putting all your prerequisites or dependencies of your application and all of the things that you are needing on the deployment. Uh, by putting them into the images, it will make your deployment times faster. It will make them more efficient. It will get you a consistent application environment. By that means, every time you want to deploy your application, you will have something that you know that you have been building, you have been deploying into it. So it's just great. Then also allows you to remove your unwanted packages that you don't want from the original images that we get from the marketplaces or the Docker hubs or wherever we are taking our images. Also, you have to remove the necessary weight, like maybe there are files that we don't need. Again, packages that you don't need and are just adding weight. You can make your images lighter. Also allows you to treat your images as code, which is great because probably everyone likes to be like in the position where you can see things as code. Terraform is an option of it. You can always stand up your infrastructure via the UI of any of the cloud providers or doing Docker commands. But then uh, always you want, like, if you have the code in front of it, you have a source of truth of what you have in there, and then you can see it in a position when you don't have to be navigating through screens, that kind of stuff. I really love how can we see our code as a source of truth, and now our images and in our infrastructure using by Terraform and Packer, for example. You can also secure yourself, and I think is the most important thing. Like we are using something that someone deployed, and you know, like what they put in the marketplace, if it's secure, if it has I don't like, you don't know, like you are not testing it by using it. You have to get it and then test it, and it just becomes like a process that I'm trying to explain here. Like it eventually becomes the process that I'm trying to explain here. But you can do a few things to secure yourself by building your own images. What are the current situations and well, some of the pains of DevOps, right? Like the part of the endless tech debt, and I have seen that a lot. And well, I mean, even because you're surprised, like all the companies have those, and it's matter of priorities. It's always matter of having time for doing stuff. Some teams are building their images manually, which may be okay. Like you can get a lot of benefit by doing it automatically or in a release process, but then some people just rather doing manually. But also they don't know better. Like maybe they just were teach to do their AMIs in AWS in the console, stop the instance and do your AMI. But well, I mean, there is better for sure. There is a lack of motivation to do it. There is a lack of motivation to automate sometimes, and some teams are overwhelmed by operations. Some teams also feel that is not needed, like they are okay by doing all on cloud in it. there is some benefits on doing it in a release process, but then it's just people that do not see that benefit yet. But also they are afraid that it could be a pain to maintain this release process, and I mean it could be, but I am pretty sure that if you follow some of the following slides that I will give you, probably you will find in less pain that you were before. But well, eventually, like a whole release process is really needed. Well, probably like it depends pretty much on your situation, your company, how big your deployment is. But also, a release process can let you forget about the same process of building images. It's just a matter of putting everything into the CI, putting everything into the GitLab, for example, and let it do the work for you. And then by doing this in a consistent way, by doing this in an automatic way, you can add value to these images and give them golden images so they can use. That means the images that they will use on their deployments, they will use it on their production deployments, and they will work flawlessly. Also, it gives you peace of mind of what you deliver. I think this is one of the things that should be a main motivator to do it. That way you can have the peace of mind that whatever you are putting in there, it's valuable, and also it has run through a set of tests, to a set of release process where you were able to detect if there is any issue before of hand. And also it gets you easy access to the latest images. By that means you get to query these images via API. You get to query these images via your own API, even like if you create one to get this, you can do this via Slack. Like you can provide a lot of ways for the users to consume your products. So it's time for, well, it's just a short story on why do we got into this thing of getting a release process for the images. So I was working for a company here in Bellevue, and eventually information security told us to get and deliver an AMI for the whole company to use as a base AMI for their deployments. The AMI, some of the part of the security they were requesting is just for an AMI that was patched. And eventually we had a process, but it was a bit messy. So we started to, I started to work on it. And after a year and a half of working through it and doing it to what I consider like perfection of what I wanted to do, I eventually get into a huge release process where the teams were able to do it by themselves, their own code, and then deploy their own images with the necessities that they have. And I want to talk about Packer if you don't know it. I probably there has been someone mentioning Packer, but then it's some people does not know it, and then it lets you build your images out of code. It lets you build in an automated way. That means you just write your code, run the Packer command, and you will have your new and brand new image that you will be able to deliver. Let you have some consistency in your image builds. That means you will build on a same way or in a consistent way every time. That way you can deliver consistency also on the images that you get to your users. And also works with a bunch of cloud providers and technologies, even Docker. So I really recommend it, and I am very comfortable working with it, and I have been working with it for 3 years now. So and now I want to talk about the requirements, or what I had an opinion of what requirements I wanted to deliver. First, it has to be delivered by self-service. That means the user should be able to get there, download the code, put their code in simple steps, and then be able to start building their own images in the same release process, and not everyone in their own repos. You have to have easy access to the latest images. Like I was telling, like how can we get the users to query to get access to the latest AMI, to the latest image that you will use. You have to have this easy of access for them to do it on their programs, to them to do it during their processes. It has to be based on templates, and that's part of the self-serve thing. Like if I can do it on templates, then the users will only have to fill a few fields on what I call the variables, for example, and then just put their own scripts, and they will have their images starting to run on the CI. You also have to differentiate between your test and prod images. So if someone is testing a new process in their images, they will be able to deploy it through all the accounts, to all the environments that we might have. And then if these changes were okay, then we can put it into a production state. Also, it has to have some automated testing for us, and also to get some security that it will be working 100%. And obviously, it should add some security, like least access, audits, restrict sudo, ACLs, remove unnecessary packages, and also patching the installed applications, and get some cadence to them, like build frequently to get these AMIs or images constantly. Also, you may add configuration management if that's something you have, and harden your security too. And probably, okay, the image is a bit blurry, but then I can explain a little bit of how the release process looked like. You have basically the DevOps user. This user will need a new image or to modify a new one of their images. So they will code their changes either in scripts or on variables in a branch, of course, not in master. Then this DevOps user will push their changes, and from there the CI will take on. So the CI will configure the environment depending if we are doing this on a master branch or on a WIP branch. If it's come from, for example, from a pull request or from a merge request. And then the CI will validate the code and make sure that it's valid. Then the CI will start building a base AMI for us. This base AMI was able to use by any team at that time, but then some other teams wanted to build their custom images. For that, we tested this base AMI, and if the test was okay, then we'll start building the custom images. If the custom image builds correctly, then we will proceed to building the other environments and so on. Once all the production validation and deployment has been performed, you will be able to release your images by all means, or whatever that means, sending a message in Slack to a channel saying, okay, we already built our images. These are the IDs that you can use to do your own testing or run through your deployment testings, and etc. But then basically give them the certainty that what they are using at that point, it was already tested and it was already approved to be used. It became as simple as tagging or naming your images correctly. That means, for example, in our case, the pipeline runs on a work in progress branch or on another branch that is not master, it will be tagged as non-production. On the other hand, if it comes from a pull or merge request, then the release tag will be production. That way, the users can search by their filters. If they wanted to test something, they will use the non-production tag, and they will search for the images that they will use. Or also, if they wanted to use now on their deployments on production, they can look for this tag. Also, something that we found is that you have to build in stages. That means you have to build your base images in the test environments, then go again to build over that base images, your custom images in testing again. And then if you have production environments, you might have only one environment, but if you have a production environment and you have differences between both of your environments, then you need to do the same, like build in stages. Also get cadence between your builds, because you might have resources that are limited, and these will help us to get some kind of consistency between builds. So also it's important to build a cumulative updates. This will reduce our build time and will get rid of unexpected build issues. What I mean for building a cumulative updates, it's you need to build your images out of your latest image that you created. For example, if you're going to patch that image, you will just run again jump update, apt-get, upgrade, or whatever you're going to do, and it's going to pull just whatever you have not been, whatever is new, whatever is new from the last image, will not pull everything that is new since the last time that CentOS or Ubuntu released an image. Also, I was mentioning about the templates and how important was this for self-serve. You can create a template and then the variables will be injected into the template. And then the Packer template should be universal, really. Like you have to have one single Packer template and then start filling as soon as you are going through the steps on the CI. Also get the CI to do the hard work like that. That's why is there. And I think it's very important to mention that GitLab has been very good at it, and I'm not trying to sell it, but it has been great to work with them while I have been doing the CI CD for this Packer thing. And about getting the testing done, this is about building meaningful testing, and not just testing by testing. This means you can test your packages versions and if they are installed. You can do security testing, like for example, if your sudo files are okay, your firewall's rules match, users and group, get a read record and what is installed and compare it. Even run a scan through it if there is any malware or anything that we didn't notice. And also, get a status and health about your packages repos and make sure that they are available for the users to use to when they get it. And also, I want to talk about how GitOps and SlackOps have been critical for a process like this. That means whatever we have in Git for this case is your source of truth. It means whatever you have in there is whatever you're going to find in your image. I think it's very important to have that for the users to be able to say what version of Java do I have installed on this AMI, and to be able to see on a build log or on the code which version of Java they have, and trust that log. Also, you need to protect your master branch. That means do not allow anyone to push directly to master, but instead be able to get pull requests or merge requests. And also you need to clean up your branches. That's something like we found, like you need to clean up whatever you have in there, because eventually if you are doing too much branches, you will get up and see how many branches you use or all are there. And also Slack Ops, I think, has been great because it has been a great way to communicate that there has been a change or there has been a new image created, and you can get there and get the latest image. Also, it's important if your pipeline fails, let the users know that it's failing and the builds are failing, so their images might be delayed or they should not be using certain images, and we can start communicating by there. And also, I want to mention, like, you're free to use the tools you want, but you can get the concept out of them and what I'm trying to say. One, like, more good practices that we found around it, it was you need to clean up after building and all stuff. Packer is very good at cleaning up if something fails, but there are sometimes like very uh, like when something is not right in your build, in your security group, for example, in AWS or in your security in Google Cloud, you might be ending with orphan instances around there. You have to clean those too, and be sure if you can do it in an automated way, it would be great. But also the old stuff, you don't want to end up with 3 months or more of images that you are not using anymore, because they might be costing you because of the space they have to carry. Also, don't put secrets on your images. Do not put tokens. Do not put password. Do not put certificates. Again, like it's something that you can inject once you are doing your deployment or your application by using Vault, by using Secret Manager on AWS, like there is too much things that you can use right now to manage those that it just doesn't make sense. And also restrict the account that you're using to build. Like a lot of people wants to build in the cloud. Now, this cloud, you are going to be accessing by using your some credentials. Do not use your personal account. It may be too open for someone to hijack them. So what you can do is create a new account, create a new profile, create a new way for somebody to get the account, and they will not be able to do more than what Packer does, which is stand up image instances and create images out of it. And eventually, how we delivered this product, it was something like this. Again, sorry, because of the image doesn't look that right, but then the user was pushing code to Git, then GitLab we do the CI, we do the pre-configuration. GitLab we run the CI, by using the CI we'll run Packer. Packer will start an EC2 instance. It will run our Bootstrap, which means we run a init script where we will install some of the prerequisites, like it could be Git, it could be wget. Like we can install or we can do a lot of stuff on the Bootstrap. It's just like preparing for the real run and configuration of the image. At that time, we were using Puppet to configure it. And also, then you had Puppet will do a lot of configuration, of course, and will do all of this stuff for you. But then you have the post process, which means then you have to secure whatever you have built and to leave all the logs closed if that's possible. Get, for example, users that are not needed anymore, delete them, delete groups, delete pseudo rules that are not used, delete authorized keys that don't should be there, and shred all these data if possible, just to make sure that this do not get leaked or something. And then we proceed with inspect testing. That was something that we were doing at that time. In inspect, we'll go and run some testing just to make sure that the packages that we wanted, they were there and they were there in a version. Then we stop the Packer will do the stop of the EC2 instance. It will save the AMI and will copy to other regions if you do that, for example, in AWS. And then you have the release process and announcements. At that time was Slack, but then they were also able to pick the latest AMI on filters on Terraform, filters in Packer if they were using it after our process, and then the AWS CLI again. Like it's just like a lot of things that where they can get this information. And this is how the pipeline looks. But then I can rather show you about what I'm talking about. So I have a coding here that I'm going to save. Now I'm going to push it. The change was we will do an echo and we'll say done with the HashiCorp 2020. We'll push the change. We will do my change and then we will push it. And once we push, you will see later how my pipeline is starting to run. It's important to say like how GitLab puts your pipeline in a nice way. Probably some other CI tools will do, but I really like the output of GitLab. And your CI will start to run. In the meantime, I can show some of the code that is in there. As I was saying, the Packer template should be without anything hard-coded, unless it needs to be there. Like it's there for all the builds. Like we're only building CentOS images. Well, it makes sense to build this into it, but you can put it into a variable later and just express it like this way. And then again, nothing hard-coded. You can see how we'll be adding tags for it and tags for everything. And then one important thing, we will be testing. We will be testing, for example, the current version at this point by using inspect. We'll shred information too. And let's see how the build is running. So Packer has started to run, and you see how it found an image by itself, and it will start to build the process. Now it will add the tags. Now it's waiting for the instance to become ready. Now the situation has to become ready to start to continue building. I think I'm still on time. Another important things in here, the CI file, and all of this is in my repo, and I will point it later during the presentation. And you will see how we will be building in 4 stages, and then you can start doing and doing your tags in here. For example, changing your tag, changing the number of your image to do that. Then let me show you a little bit more. It will, so Packer by itself, it has started to build the image by having an instance up and putting stuff into it. Like for example, right now is trying to patch it. Some other important things while that gets done, you will see the testing, and I really feel amazed of how many people have been using InSpec and GitLab, but then they do a very good match. And you can see the simple as this. They look the you can look at the test. In this case, we will test curl. It should be installed in a certain version. The same we will test the InSpec like an example. And for to end the code, I can show you. We have a template with some variables in here, like region or what versions are we testing. And then and in the scripts, you will see how we have our bootstrap, our post process in there. And these scripts are just simple scripts that do some steps. So now that I probably can show you on another pipeline that I have run, because probably it's going to take some more time. But then you will see how in here, something that I feel that is very important and InSpec brings to is how can you test your images during the build, and that way avoid building something that is not going to work. For example, in here it's telling us that this package is expected to be installed in this version. It all matches, and then also InSpec is installed. So it will let us know our image and what's the AMI that we built, and that's it. Like you will have your image in there, and then you will have delivered through all the stages of the release process. I will come back quickly to the presentation, and to get in touch with me, well, that's my Twitter, that's my LinkedIn. The code example is in there. The presentation is ready on the forum, so it can be shared too. And then I want to thank Sanyo Melwani, Colin Spargo, Lee Briggs, and everyone at Apptio that really contributed to this project too, and also my family.